For this video, I'm going to be showing the distance vector simulator and showing how it works, explaining the steps that it takes in order to find the shortest path between the four nodes. Here's the example. As you can see, there's going to be four nodes, and it shows the cost of visiting each node through the links. And the simulator, running correctly, should find the shortest path. And I calculated the shortest path here using an Excel spreadsheet. And as you can see, these match what are the known costs for the nodes initially before they send messages communicating to each other. As you can see, node 0, here are the known paths it could take to reach each node. Node 1, as you can see, it knows the cost for going to 0 itself, and then 2, but at 3 is 0. 3, the cost is infinite, since here I labeled blue because the cost is unknown. For node 2, it knows all the costs of going to each and every node. For node 3, as you can see, it doesn't know the cost for node 1. Now that's for the initial round. And then the second round, once the routers exchange info and update, node 0 learns of a new quicker path to getting to node 2. As you can see, compared to before, it was at 3, now the cost is 2. Node 1 updates as well. Node 2, as you can see, updates. So does node 3. And again, you're going to go through another round of updates. The values are going to change. As you can see here now, all the nodes now know the cost to each other. None of them have infinite cost. And finally, at the third step, this would be the information that the nodes know about what is the quickest and shortest path to travel between any of them. As you can see, for 0, if that was your starting node, the path would be 0, or the cost would be 0, 1, 2, 4. For the cost of 1, it'd be 1, 0, 1, 3, 2, 2, 1, 0, 2, and if your starting node was 3, it'd be 4, 3, 2, 0. And as you can see, they all had the same table, because that would be the agreed shortest path. You know, it's different from here. Here they were updating, here's the final. Now with that being said, knowing this is the shortest cost, if we run the simulator on C, which we have here, the simulator should get the same results that I calculated. So let's build that. Alright, that's all correct. Let's get it started. Alright, let's put trace here. Okay, make that a little bit bigger. Alright. As you can see here to start off with, if we're at node 0, our known costs are 0, 1, 3, 7. And if we bring up the Excel sheet, give 1 second. Okay. Move over. What do we have here? 0, 1, 3, 7. Same as here, 0, 1, 3, 7. Alright. Let's go down to source 1. Source 1, okay. Here are the costs. 1, 0, 1, negative 1. What do we have here? 1, 0, 1. The negative 1 here being infinite because it doesn't know the cost. And my Excel should have it as blue. Alright. So for node 2, we should have 3, 1, 0, 2. Or for the simulator, it should be 3, 1, negative 1, 2. Let's see, source 2. Alright. 3, 1, 0, 2. Okay. There we go. You got the cost. Alright. For node 3, the cost should be 7, infinite 2, 0, or 7, negative 1, 2, 0. What do we have here from source 3? 7, negative 1, 2, 0. So these are the initial costs, which match up here. That's correct. And if we move over, the costs are going to change. So as you can see here, the simulator first starts off by going, hey, node 1 found a better way to node 3. Okay, through node 0. So here it explains. It updates 1018. And again, you can see here, it updates again. Node 1 found a better way to node 3 through node 2. It gets the cost of it being 0, 1, 3. 1013. Alright, that being found, as you can look here on my Excel sheet, for cost of 1, it's 1013. Look all the way at the end, that's going to be the final cost for node 1 going through all the nodes. So that's correct. Let's take a look here. Node 0 found the better way to node 2 through node 1. Again, here you got it updating. You got another update. Node 3 found a better way to node 1. Here, you can see the final update for node 0. Node 0 found a better way to node 3 through node 2. And you get the cost 0124. You look up here. Node for the final cost for node 0 would be 0124. So that's correct. For node 3, as you can see here, node 3 is updating. Node 3 found the better way. Cost is at 5320. Again, you got here, node 2 finds a better way to node 0. Cost being 2102. What do we have here? 2102 again for the final cost. So that's correct. And here finally node 3 updates with getting its final shortest path of 4320. What do we have here? 4320. So with that being said, as you can see, the simulator is running correctly. It's communicating through the steps that it takes, updating each node. And as you can see here, for example, the final table shows at source 0, right at the top, right here, or at source 2, I should say, to source 0. The shortest path is 2102. Again, that's what we have here. And here at the very bottom at source 3 to destination 2, you got the shortest path being 4320. That matches up here. So the simulator is correct. It does find the shortest path, which I calculated on the side here. So that's correct. And with the shortest path being no, just check it. Although we know it's running correctly, I found an online simulator and I created the same known paths. As you can see, you have 4 nodes here. Instead of them being labeled 0 through 3, they're just A, B, and C, D. The costs are all the same, just like here in the book. And if we follow it, here I'm going to run it. I'm just going to step through it, right? If we start here, the simulator only will start from the first node. So we'll just pretend that's A stands for node 0. Following Dijkstra's algorithm, it's going to take the shortest known path. Here, shortest known path from A is going to be 1. So we'll step through. As you can see, lights up, goes to node B, which in this case would be node 1. If we're following the picture here, and if we follow the calculations that I made, as you can see, the shortest path is 1, shortest cost. Following my costs that I calculated, it should go to node 2. So let's see that. Let's keep stepping through it. As you can see, goes to node 2, just like in the picture. As you can see here. Again, the shortest path or cost being from 0 to 1, from 1 to 2. Again, the same thing that's here calculated, going from 0, 1 to 2. We're going to step through it again. Here we go to the last node, C, which is node 3 in this case. And then the simulator ends. And so following these two simulators, the one online and the distance vector one provided in class, we can see that they follow the charts that I calculated and that they are working correctly.